so many values in an inverse, it's tough to keep straight what's what. And so when we get toward the end, I'll show you a way to keep track of all the different numbers and hopefully make sense of them. We'll get there. First, a word about notation. 3 to the negative 1, right? A negative exponent flips it over. So 3 to the negative 1 is 1/3. 7 to the negative 1 is 1/7. And so on. X to the negative 1 equals 1 over x. That's fine. That's good. Oh, that's a question. So yes, that's true. But what about sign with a negative 1 there? Do you remember what that means? That means inverse sign. So it doesn't mean flip it. It means inverse sign. Which is sort of a backwards thing, right? Like, if the sine of pi over 6, what's the sine of pi over 6? Pre-Cal All-Stars. 1/2. Then what's the inverse sine of 1/2? The inverse sine of 1/2. That means what angle has a sine of 1/2? Pi over 6. Those are backwards operations. They undo each other. They're inverses. Sine of x is not a variable. Sine of x is a function. When you see a function with that -1, where we normally think it's an exponent, it does not mean 1 over the function. So that does not mean 1 over sine of x. It means inverse. The -1 exponent means reciprocal. That's kind of what we're used to. If it's a number or a variable. But if it's a function, it means the inverse of the function. So we have to be careful. F to the -1 is the inverse of f. It has nothing whatsoever to do with 1 over f of x. So the -1 is a little bit tricky. Right? If it's a number or a variable, flip it over. That's what we're used to. But if it's a function, it means the inverse of the function. So g to the -1 is the inverse of g. We're going to be finding the derivative of a function's inverse. So we need to think how we would write that. The derivative of the inverse of f. Okay, well that's the inverse. The derivative is the little prime mark. So this is going to look funny. There's the inverse. There's the derivative of x. We haven't even talked about how to find it yet. We're just talking about how to indicate that's what we're looking for. The -1 is the inverse. The little prime thing is the derivative. So this is the derivative of the inverse of f of x. Okay, well, let's remind ourselves what inverses are. We had this lesson in Algebra 2 just a couple days ago. F and G are inverses. That would mean all the following are true. If AB is on the curve of F, then BA is on the curve of G. So let's just pick a point. Let's say that's point AB. It reflects across, and this point would be BA. The X and Y get switched. If I can't remember that from inverses. You switch x and y. If you want to find an inverse of a function, you switch x and y. So you can switch the x and y of the points. This means that if f of a equals b, then g of b equals a. You can switch the x and the y. Two curves are symmetric to each other. Across y equals x. The example here is f of x equals e to the x. That's e to the x. That's natural log of x. Those are inverses of each other. And long ago, you might remember having to do this on an Algebra 2 test, maybe even a pre-cal test. Use composition of functions to show that f and g are inverses of each other. Physics labs, maybe? I don't know. So all of that is Inverses. That's algebra. We still haven't done calculus yet. That's inverses. Okay, now we're going to look at the derivative of an inverse. We're going to start with the reminder that if f and g are inverses, then f of g of x equals x. Again, this is on the next Algebra 2 test that we have. We'll have to be able to show that. Let's take the derivative of each side and see what happens. So the left-hand side, that's going to be chain rule stuff. So f prime of g of x. That's the outer wrapper, right? That's taking care of the f. Then we move to the g prime of x. And then you could even put the times 1 on there if you want to like go all the way down to the Tootsie Roll Pop stick thing. The other side would just be 1. Right now, if we solve for g prime, it's going to look funny, but it's not hard to solve for g prime. We're just going to divide by all of this. So g prime of x is 1 over f prime of g of x. You're not going to have to go through this every time, but the takeaway is that inverse functions have reciprocal derivatives. Inverse functions have reciprocal derivatives. Inverse functions have reciprocal derivatives. That's kind of important today. Inverse functions have reciprocal derivatives. The trick is keeping track of who's x, who's y, but then we flipped x and y because they're inverses. That's kind of the tricky part. We'll show you the table method here in a minute. So if f and g are inverses of each other, then this part isn't really what I'm about to write. You're not going to remember this part. That's okay. We'll use it to build this table in a moment. F and g are inverses, then g prime is 1 over the derivative of f prime. But the points got switched around because AB versus BA. So G prime at B is 1 over F prime at A. All right, let's break this down in a little bit easier way. All right, so we got F and G, we got a point, and I'm just going to call it y prime because, you know, it's the derivative of f or the derivative of g. This is the table that I want you to build every time you do one of these problems. And if you'll build this table, you'll get it right every time. Like, there's lots of points going on, but if you'll build this table, and the conclusion is going to be that these two things, those two boxes, are reciprocals. I ran out of room. Reciprocals. Okay, so if AB is the point on F, what is the point on G? BA, because the x and y's are switched. Y prime of F, so that means F prime at A, but this box is going to be G prime at B. And whatever you get for one, it's the reciprocal of the other. Build this table every time, and just remember that these two boxes are reciprocals. Like, that's the main point of today, is that these two boxes are reciprocals. Well, I mean, they're not reciprocal, meaning they're flipped, up and down. These two, is that what you're talking about?
Yeah.
I mean, I see what you mean. They're not reciprocals because they're not 1 over A or 1 over B, but they are, the X and Y are flipped. That's true. But that we don't use the word reciprocal for that kind of flip.
Is 2 just a constant? F2.
Sorry, that says point. And the reason I want to build the table every time is because in these problems, they end up giving you all sorts of information. And so you got to figure out what information did they give me, where does it go in that table, how does it help, and sort of work your way around to filling out the table. Okay, this will be easier if we do some examples. F of 2 equals 5. F prime of 2 is 1/3. What is the derivative of the inverse of 5? I don't know. That's a lot of information. So they didn't tell me G. They said inverse, but that's okay. I can deal with that. So let's build our table. And again, the big deal is that our final answers here need to be reciprocals of one another. So what's the point? What's the point? Somebody may be asking that. What's the point of this? What's the point that goes with F? 2, 5. X is 2, Y is 5. So my point is 2, 5. What's the derivative of F at 2? 1/3. Well, regardless of what else is going on, I know that 3 goes in this box because those are reciprocals. But let's fill out the rest of this table here. So what's the point for the inverse? If 2, 5 is on F, what's on the inverse? 5, 2, because they switch around on us. So what is the derivative of the inverse at 5? It has to be 3 because those are reciprocals. And that's exactly what it asks. So my answer is 3.
So is G just another way of, on the right is G just the way to, a different representation?
Correct. I guess we should say on this, F and G are inverses.
Okay.
Yeah. G is the inverse of F. So again, if you don't fill out the table, it just gets too confusing on, 2 and 5, but who's X and who's Y? And there's a 1/3, so I flip that over, but what do I do with it? So the table helps us keep organized. So anytime you're asked for a derivative of an inverse, first thing I'm going to do is draw the table and start filling in the pieces. Number 2, f of x is 3x cubed plus 5. Find the derivative of the inverse of f at 8. All right, don't know much yet, but I know enough to start building a table here. And again, whatever I get at the end, those have to be reciprocals. Okay, so what it asks me for is the derivative of the inverse at 8. So what I'm going for is whatever's in this box. That's the end goal of this question. And that's another thing. They can word questions that end up asking you about different boxes. But if you set up the boxes, then you're ahead of the game. Okay, so I'm looking for this. What's the x value? Maybe I should ask it this way. Where does this 8? Where's that 8 go in my box? What is that? It's the x of the inverse, right? The stuff in parentheses is the x value, and we're talking about the inverse. So that 8 goes right there. So that would force this to be the derivative of f prime at 8. This one we're going to have to work backwards a lot. Well, if it's the 8 right there, what does that mean in terms of this point? It's the y value there. Okay, so it's the y value for the function, but I'd really like to find the x value for the function. So what can I do to find the x value of the function? So 3x cubed plus 5 equals 8. So the answer is 8. I want to know what x would get me to 8. So 3x cubed equals 3, x cubed equals 1, so x equals 1. Doesn't really matter, but that also means the y value for the inverse is 1. Okay, I want to find this box, but I don't have an equation to take a derivative of. I do have an equation of f to take a derivative of. So let's take the derivative of f. F prime is 9x squared. Cody? So, like, find the inverse of this and then find the derivative? Once I have this answer, I'll be able to flip it over to get here. Yeah, so I need to find this answer, and then I'll flip it over to put it in this box. That's what I'm going for. So my next job is to figure out what this box is, and if I can figure out what goes in that box, all I'll have to do is flip it over. So what goes in that box is f prime at 1. So the derivative was 9x squared. If I plug in 1, I get 9. So 9 goes there. Now it's easy. What's the reciprocal of 9? 1 over 9. And that's the box we were looking for. So my answer is 1/9. Yes, no, this is crazy. Number 3, no equations, but a table. And so now we'll be extra careful on who goes where, because the answer is hidden over here somewhere. Let h be a differentiable function. Selected value of h and its derivative are in the table on the right. And we want to find the derivative of the inverse of h at 5. So any derivative of inverses, I'm building the table, and I know that at the end of this, I'm going to use, like, those two boxes have to be reciprocals. Okay. Time to start picking on people. Maddie, what box on my table is this question even asking for? Perfect. That's exactly what I was looking for. Like, it's asking me to find the derivative of the inverse. So we're looking for that box. Like, that's what we're going for. That's the end goal of this problem. Cody, about the only thing it told me is that something is 5. Like, so what the heck is that 5? Where does that go in my table?
X for the inverse.
Good. That's the x value for the inverse. So I'll put 5 right there. Caden, if that's the x value for the inverse, what else does that mean? Yes, the y value for h, y value for the original, y value for the not inverse. Yes, whatever you want to call that. Okay?
How do you know when it's like when the 5 is the x value and the y value? Because for the first two, they're both the y value, and it looks the same.
So when it puts that number in parentheses, that means it's an x value, right? That means it's an input. but it's an input to the inverse. So that's an x value for the inverse. Same thing on this one. It's an x value for the inverse. It's an x value for the inverse. So if it's in parentheses as an input, we know it's an x, and then we just got to see, well, where are we inputting this thing?
Will it ever give us the y value and then ask us to find x? Will it most of the time give us the x value?
It's most of the time going to give you the x value of the inverse. Because, here's why. If it gives you the y value of the inverse, what does that also mean it is? It's the x of the original. So that would be an easier problem, because they would just be giving you the x of the original. Okay, so if the y value of h is 5, like that's sort of the answer, how do I figure out what x is? So I look at the table, and what am I looking for on the table? I see 2 different 5s there. Yeah, I want to know where the answer is 5, where the y value is 5, where h of x is 5. So which row is that? 1, 2, 3, or 4? Right there. So that means h is 5 when x is 10. Oh, we're getting close. We're getting close. So, Lexi, if this is the point on the original, 10, 5, this row, what does that mean the derivative of h at 10 is? Nice. So that's, this box is negative 1/4. And then lastly, the popsicle stick you want to get picked for. Tristan, what does that mean goes in the yellow box? It would be -4, because all I have to do now is flip it over. So let's make sure we answer the question. The answer is not my table here. The answer is -4. But goodness, look at all those numbers and how to figure out where they came from. Part B, write the equation of the tangent line of the inverse at the point when x equals 7. Okay, well, let's set up the table again here. Point, derivative. So the equation of the tangent line means I need a point and a slope, so that's like, I'll use all of that to get me a tangent line, right? I'll need a point and a slope. Let's see. I'm going to turn you loose on this one in a moment. But when x equals 7, this is a tricky one, because definitely x is 7, but x is 7 for what? The original or the inverse? Because I want the equation of the tangent line of the inverse when x is 7. So where's that 7 going to go? The inverse. So that 7 goes right there. Which means that 7 also goes right there. Which means now you can start working your way around. You know those will be reciprocals. Why don't you see how far you can take that one on? When x is 7 for h prime, that means y is 7, or no, not prime, but the inverse. That means y is 7 for the original. That happens, running out of colors. That happens right here. So that means that's 3. It also means that's 3. And then from that same line, I can find the derivative. The derivative of h at 3 is -3/2. And then I flip it over and get -2/3. Usually that's the answer that the question is going for, but this one wants the equation of a tangent line. So I need to use the slope and the point of the inverse So y minus 3 equals negative 2/3 x minus 7. That was pretty good. I think most of you got it, and if you didn't get it, you were close. You made some minor mistake somewhere. Number 4, if g equals the inverse of f of x is the sine of 3x, x is between 0 and pi over 4, then g prime of 1/2. Okay, this is another example of why we make a table, right? Because there's, like, I can't make sense of all of that information. That's too much information to think about at once. So I want to organize it with my table, and then we'll figure out what's going on. Okay, so Hector, first question. It wants g prime at 1/2. So which box on my table is it even asking for?
The bottom right.
The bottom right. That's what it wants. The derivative of g. That's what we're looking for. So that's the end goal here, is like what goes in that box. Alec, that 1/2, where's that go?
It's
The x of the inverse. Yep, it's the x because it's in parentheses of g, so it's the x that goes with g. Zach, what would I fill out next, or what goes next in my table?
It would have to be the y.
Yep.
It's, you put g down there, but it says 1/2 is x of g prime, not g.
And so that's what this will be, because this will be g prime right here. But we'll find it plugging in 1/2. Yeah, the x value is the same. Okay, so now I know the y value of my original function. So, Braden, what am I doing next here?
This is probably wrong. Is the other value, is it pi over 18?
Ooh, I don't know. Where did you come up with that? You might be right. Like, how did you get that?
Because sine of 3x is doing something with 3.
So what does sine of 3x have to equal? 1/2. So I need the sine of 3x to equal 1/2, and then I need to work backwards to figure out what x is. I think you're right, though. So if the sine of x equals the sine of 3x equals 1/2, that means, like, you can ignore the 3x for a minute. If the sine is 1/2, hey, this is what we started with 28 minutes ago. If the sine of x is 1/2, what does that mean the argument is? What has to be under my pin? I mean, I know 3x is there, but the sine of what is 1/2? Pi over 6. So that means that 3x has to be pi over 6. So Braden, yes, you can celebrate, because yes, that means x is pi over 18. Okay. Trying to ask less leading questions and more like just simply, what's next, Marie? What should I do next? So I want to get to here, but I can't get there yet. If I could get this box, then I would just flip it over to get this box. So is there a way I could get this box? That's what goes in that box. Just tell me that. What goes in that box? Like, not the number, but like concept. What goes in that box? Okay. I don't know that I'm asking the question very well. Does anybody know what I'm trying to ask? Like, what conceptually goes in that box, Laura?
Derivative of f.
The derivative of f goes in that box. So I want to take the derivative of f. Oh, I have a function of f, so I can take its derivative. f of x is sine of 3x. So, Helen, what's the derivative of the sine of 3x?
Cosine 3x times 3.
Nice. Cosine of 3x, and she remembered the chain rule. Of course she did. Okay, but I don't want to put 3 cosine 3x in the box. Evan, what do I need to do before I fill out that top box there? Because it's not like generic y prime, it's y prime at the point.
You have to plug in.
Yes, and what should I plug in?
Pi over 18.
Pi over 18. So I need to plug in pi over 18. Now, I don't usually write at the point because that kind of clutters up my table, but that's what it means. Y prime at, maybe even better, at the x value. So I want f prime at pi over 18. 3 cosine 3 pi over 18. 3 cosine pi over 6. Leah, cosine of pi over 6? Give you a pre-cal question. Yes. So that means that in this top right box, that's the derivative of f at the x value. The derivative of f at the x value is 3 root 3 over 2. Which cruelly is answer choice C, but it's not answer C because what do I need to do to get into the yellow box here? Flip it. And I don't even have to fix it, I just need to flip it over. 2 over 3 root 3, answer choice D. Has your head exploded? Is it still intact? Nearing explosion? Why don't you try, let's see, try part A. You know what, we'll, if you can do, we'll skip B and C and do some of the worksheet together. Try part A, so another one that's on you, start to finish. Almost always they're asking for this bottom right box. Almost always that's what they're asking for. And you got to figure out what goes where to land there. Let's see, 1 looks familiar, 2 looks familiar, 3 looks familiar, 4 is one with an equation. Marie, should we do number 4 since it has the equation in there? We were concerned about that one. We felt like the tables were easier than the equation. So let's do number 4 together. Let f be the function defined by that thing. G is the inverse of f. G of 3 is 1. What is the value of G prime of 3? Again, when I first started teaching this, I didn't use the table, and I couldn't keep up with all the information. And so I probably saw somebody use the table, and I just thought, that's fantastic, because now I can keep up with everything. Point and slope. Okay. So, I guess, Trevor, tell me something I know. What can I put where to start this thing? Or you could tell me what I'm looking for. Which box am I going for? The bottom right box. So, my answer will be whatever lands there. All right? Sayla, what else do I know?
That at G of X, or when you plug in X equals 3 for G equals 1.
Okay.
The point would be 3, 1.
Perfect. The point would be 3, 1. That's great. Avery, how does that help me? Like, what do I do next?
The F points are 1, 3.
Yep. F point is 1, 3. Okay. So what's next, Elizabeth?
You take the derivative of f of x.
I thought you were going to say more, but that's fine. We'll take the derivative of f of x. 3x squared plus 2x plus 1. Will, what do I do with that?
What are you?
Sorry, I'm on number 4. I found...
The derivative, then you plug in 1.
Good. I'll plug in 1. F prime of 1. That's nice. 3 plus 2 plus 1 is 6. So, well, I don't know how a blank popsicle stick got in there. Somebody erased their name or just disappeared. Ryan, what do I do with 6? Where does the 6 go?
The 6 goes in the F.
Yes, I assume you meant there.
Yeah.
The derivative of f.
Yeah, and then the derivative of G, or like on the bottom would be 1/6.
It's going to be 1/6 because that's a flip. Yeah, we're just like peeking ahead. Number 6, look at all those numbers. But if you organize them in a table, I don't think 6 is really that hard. Let's see, tables, functions, tables, functions, tables, functions, tables, functions. Tangent line, yeah. Sophia, what's up? Hold on. Shh, what'd you say? Do 6 and... What about it? F and G are differentiable. F of G of x is x. So they're telling me that F and G are inverses. So I'm still thinking that this is my best bet. F of 3 is 8. F prime of 3 is 9. 6 might be the easiest one on there, if you build the table. F of 3 is 8, so that means the point is 3/8. The derivative of f at 3 is 9. And they're basically just asking, well, what's in the bottom row of the table? So, flip the points and flip it over. Go ahead, Will. 8, 3, and...
I was doing it in my head. I was trying to do it in my head.
Well, you can do that in your head, right?
I didn't see you put the table.
Oh, okay, yes. And that's the point of the table, is like the table makes it easy. Otherwise, there's too many things to keep in your head, and like, where does it go and how does it flip? But if you draw the table out, it's pretty easy. And I guess I never noticed it. That, like, this is a kind of a left-right flip, and this is an up-down flip. And yeah, now 6 is easy. But before the table, it's just like, numbers everywhere. Where do the things go? Well, organize it, and then you're okay. That's the hope. Okay, our test isn't until Monday, so I'm just peeking ahead. I'll answer some questions from the review tomorrow, and then we'll be ready to test on Monday.